You know, usually when we talk about something like a medical diagnosis, there is this very deep fundamental expectation of precision.
Right, absolutely.
I mean, it's basically like engineering. You fall off a bike, you break your arm, and you go to the hospital.
Yeah, and you expect a clear answer.
Exactly. They
Yeah.
put you in front of an X-ray machine. That machine takes an image based on the physical properties of your bones and, the radiation passing through them.
Mm-hmm.
And the resulting image shows a jagged white line. The doctor puts that image up on the light board, points right at it, and says, well, there it is.
Yeah.
That is the fracture.
It's a completely binary state. I mean, the bone is broken or the bone is not broken.
Yeah.
There is a physical, observable ground truth that the diagnosis is actually built upon.
It's clean. And psychologically, that is incredibly comforting for us.
Oh, for sure.
As humans, we really like things to be visible, to be mathematically categorized, to be known. We rely on systems that give us absolute answers.
We do.
But when you step into the world of artificial intelligence today, I mean, the systems that are increasingly being integrated into our hospitals, our banks, our infrastructure, suddenly that X-ray machine is broken. We are looking at a diagnostic landscape that is just entirely murky.
Murky is almost an understatement, honestly. It's the absolute definition of diagnostic muddy waters.
Yeah, that's a good way to put it.
Because over the last few years, the lines between what is a mathematically calculated fact and what is just a highly probable, statistically generated guess, well, they've been completely blurred.
Right.
And that blur is happening inside the black boxes of the most powerful technologies we've ever built.
And that blur, the sheer danger of it, and a pretty radical solution to it is exactly what we are exploring today. So welcome to the deep dive. We are thrilled to have you with us because, well, today's stack of sources is just unlike anything we have looked at before.
It really is. It's fascinating.
We are diving into this uncompromising counter-movement in the artificial intelligence industry. We are looking at a proprietary system called Construct OS and its user interface, which is named L.O.R.I.
And, the system wasn't built by a massive tech conglomerate in Silicon Valley.
Right.
It was actually built by a single independent architect named James Mark Price. And the source material you've given us to review is dense.
It's so dense.
But it's fascinating. We are looking at architectural blueprints, raw terminal compilation logs, technical white papers, and a very passionate audio manifesto from Price himself.
Yeah, where he lays out his entire philosophy.
Exactly.
The core mission of this deep dive, what we really want to unpack for you today, is why this system completely rejects the way modern AI is currently built.
It's a total rejection.
Because the fundamental premise we are dealing with is this. The AI models that you and I use every single day, the ones making global headlines and securing billions of dollars in venture capital funding, they are fundamentally built on probabilities.
They are. They're guessing engines.
Yes, guessing engines. Construct OS, on the other hand, is built on absolute, unyielding mathematical certainty.
It is a complete paradigm shift. And to truly understand why Price felt compelled to build this incredibly rigid, mathematically governed system from scratch, we first have to explore the environment he's reacting against.
Right, what he's pushing back on.
In his manifesto, he identifies a core flaw in the current state of the industry, a flaw he actually calls the mimicry fallacy.
Okay, let's unpack this. The mimicry fallacy.
Yeah.
Price is essentially arguing that the entire tech industry is currently stalled by a massive category error, right?
Essentially, yes.
He says that we, as a society, are mistaking human imitation, which is really just conversational fluency for actual intelligence.
And this goes right down to the fundamental architecture of how current large language models, or LLMs, actually operate. If you look under the hood of the AI that most people interact with today, it operates on a mechanism called token prediction, which is driven by statistical weights.
Okay, so how does that work in practice?
Well, these models ingest unimaginably massive amounts of human text. We're talking books, articles, websites, forums.
Basically the whole internet.
Pretty much.
Yeah.
And they analyze that data to calculate the statistical likelihood of one word or a piece of a word called a token appearing next to another token.
I see.
Price is incredibly blunt about this in his manifesto. He straight up refuses to call them artificial intelligence. He actually refers to them as casino algorithms.
Casino algorithms. That is such a vivid description, but I mean, it feels a bit harsh, doesn't it? Is it really just a roll of the dice?
From a mathematical perspective, yeah. Yes, it is. Because these models have no underlying mathematical ground truth. They
Why?
don't actually know anything in a deterministic sense. They don't understand the concepts they are writing about. They rely entirely on confidence intervals.
So it's just playing the odds.
Exactly.
Yeah.
Let's say the AI is generating a sentence and it has to pick the next word. It might calculate that it is, say, 95% confident that the next word should be apple. But maybe it's 3% confident it should be banana and 2% confident it should be car. It selects apple based on that statistical likelihood.
Right.
It is essentially pulling a lever on a slot machine where the odds are heavily weighted toward a specific outcome based on its training data.
So it's playing the odds of language, not the facts of reality. The sources bring up an analogy for this that I just found incredibly relatable.
Intern analogy, right?
Yes. It compares current AI to a charming intern. So imagine you have a new intern at your office. They are very eager to please, very well-dressed,
Yeah.
very polite.
Sounds like a great intern.
Right. But then you ask them a complex question about a client's account. Now, a good worker would say, I actually don't know the answer to that. Let me go check the files and get back to you.
That's the responsible thing to do.
Exactly. But the charming intern, who is terrified of looking incompetent and just desperate to keep the conversation flowing smoothly, just confidently hallucinates a completely fabricated response.
Oh, boy.
They tell you the client loved the proposal and signed off on it, just because that sounds like the most plausible, pleasant continuation of the conversation.
And that is exactly what an LLM does by design.
Wait, by design?
Yes. They are fundamentally engineered to generate language. Silence, or halting, is seen as a failure in that probabilistic model. The architecture demands that they produce an output.
So they literally can't just say nothing.
Right. So when they encounter a gap in their training data or, a prompt that confuses their statistical weights, they just string together tokens that sound highly plausible.
Even if the underlying facts are entirely invented?
Even if they are entirely made up. They hallucinate, but they deliver that hallucination with the exact same fluent, confident tone as a verified fact.
But wait, I have to push back on this a little bit.
Okay.
Because if we think about it from the everyday user's perspective, isn't fluency exactly what we want?
That's a fair point.
I mean, we like that it feels natural to talk to our devices. We want our digital assistants to sound human, to be conversational and engaging. So is this industry focus on fluency really that dangerous? Or is Price just being, a bit of an architectural purist?
Well, that is the crucial question. Is it a feature or a bug? And to answer it, we really have to look at the stakes of the environment where the AI is deployed.
Okay, stakes.
Fluency is fantastic if you are asking the AI to write a birthday poem for a friend, or to draft a polite, generic email to your landlord.
Yeah, or brainstorm ideas for a sci-fi novel.
Exactly. The stakes in those scenarios are absolute zero. If the AI hallucinates a weird metaphor in a poem or invents a fictional planet in your brainstorming session, who cares?
Right, it doesn't break anything. It's just a funny quirk. It might even be creatively helpful.
But Price argues that the tech industry's obsession with humanizing machines has a dark side. By optimizing for a human-like conversation, we are deliberately programming human flaws into the architecture.
Which means what, exactly?
It means we are building systems that exhibit cognitive bias, memory fade, and crucially, the ability to seamlessly rationalize a lie when backed into a corner. We are making them act like humans, and humans are notoriously unreliable data processors.
So it's not that fluency itself is inherently evil, it's that fluency acts as a mask.
Precisely.
It disguises the fact that the underlying system is just guessing. It creates a false sense of trust.
And this leads us to the core of his argument. The charming intern stops being a funny, harmless quirk the moment you move out of the realm of creative writing and into environments where failure has catastrophic consequences.
Environments like what?
Price points specifically to critical infrastructure. We are talking about the software running aviation hardware, medical diagnostics in hospitals, national defense logistics, and massive enterprise data reconciliation.
Oh, wow.
In these zero-margin environments, a 95% probability rate is not a feature. If you have a 5% chance of the system confidently lying to you about the structural integrity of an airplane wing, Price calls that outright negligence.
That transition from helpful conversational assistant to structural liability is just terrifying when you put it in the context of enterprise data.
It really is.
Imagine a major bank or a global supply chain relying on a system that might randomly guess a number just to keep a sentence flowing. And this is where Price's own professional background really informs his architecture, isn't it? The sources note he has over 20 years of experience as an SAP basis administrator.
Yes, and that context is vital. For those who might not be familiar with the enterprise software world, SAP Basis is essentially the bedrock layer of massive corporate IT systems.
Okay.
It is the technical foundation, the central nervous system, that manages a global corporation's most critical data. We are talking about financial ledgers, supply chain logistics, human resources databases, manufacturing schedules.
Basically everything that makes a multi-billion-dollar company actually function.
Right, exactly. Managing SAP Basis requires absolute mathematically strict data integrity. A single misplaced decimal point can cost millions of dollars or halt a global shipping operation entirely.
And working in that hyper-strict, zero-forgiveness environment for 2 decades, Price introduces this terrifying concept regarding probabilistic AI that he calls slow rot.
Yes, slow rot.
And he uses the analogy of an iceberg to explain it, right?
The iceberg analogy perfectly captures the danger. He says that probabilistic LLMs look fluent and coherent above the waterline. That is the interface layer, the conversational text that we interact with and marvel at.
The part we see.
But underneath the surface, in the data layer, their probabilistic nature creates this invisible, creeping degradation.
I really want to dig into how this slow rot works in practice. Because it's not like the AI just suddenly deletes a massive database, sets off a bunch of klaxons, and the IT team rushes in to fix it.
No, and ironically, a catastrophic crash like that would actually be preferable.
Preferable. Why?
Because you would catch it immediately, you would know the system failed, you would restore from a backup, and you would move on. Slow rot is insidious because it is completely invisible.
Can you give an example of how that happens?
Sure. Let's walk through a hypothetical scenario. Imagine a massive global hospital network integrates an LLM to help summarize and manage its supply chain inventory across, say, 50 different facilities.
Okay, so it's handling a lot of data.
Right. The LLM is tasked with reading thousands of daily reports and generating a unified dashboard. One day, the LLM gets slightly confused by the phrasing in a particular vendor email.
She's a little confused.
Yeah, and it hallucinates a single, plausible-looking number. It confidently reports that the central warehouse has 10,000 units of a critical intravenous saline solution.
Okay, but in reality?
In physical reality, there are only 1,000 units left.
And because it is so fluent, it presents that 10,000 figure with absolute syntactic confidence. It doesn't add a little asterisk saying, hey, I'm only 80% sure about this. It states it as a fact.
Exactly. It looks identical to a verified data point, so it doesn't trigger a system crash. No red lights flash on the administrator's dashboard. Instead, that single corrupted record is calmly accepted by the database.
And then what?
And then the rot begins to propagate. That fake 10,000 unit figure gets pulled into the next quarterly financial forecast. It gets factored into the automated purchasing system, which decides to delay ordering more saline because it thinks the warehouse is full.
Oh, man.
That forecast is then used by the hospital administrators to determine resource allocations and budget cuts for the next fiscal year.
It's like a virus that perfectly mimics healthy DNA.
Right.
It just quietly integrates into the host and replicates itself.
And because it is disguised by that fluent natural language, and because it is surrounded by thousands of other perfectly accurate data points, it goes completely undetected.
It just sits there.
It sits there, silently warping the reality of the database, until 6 months later when a hospital runs out of saline in the middle of a critical care surge, and the entire logistical chain collapses.
That is wild.
By the time the failure scales to a visible level, you can't even trace it back to the original hallucination. Price points out that a single unflagged guess can silently destroy decades of earned historical data integrity. You are essentially poisoning the well from the inside out, drop by drop.
What really strikes me from reading the manifesto is his point about the absolute impossibility of fixing this after the fact.
Right.
He says that trying to patch a hallucination after it has already corrupted a database is basically an admission of architectural defeat.
It is.
If your core system is designed to guess, and you are just building secondary alarms, hoping to catch the bad guesses before they ruin your company, you have already lost the war. You can't bolt security onto a foundation made of sand.
You really can't.
Absolute safety, absolute truth, can't be an afterthought. It has to be the structural floor of the operating system itself.
Which brings us perfectly to the core of what Price actually built in response to this crisis. If probabilistic AI, the guessing machine, is too structurally dangerous for critical enterprise data, what is the alternative?
Yeah, how do you build an artificial intelligence that is physically, mathematically, and structurally incapable of lying to you.
Enter Construct OS, which the blueprints also refer to as Project Adam.
Okay, Project Adam.
Yeah.
This is where our deep dive gets incredibly technical, but I promise you, the underlying philosophy here is absolutely fascinating once you see how it works.
It really is.
Price didn't just build a new chatbot. He built a mathematically governed operating environment. It's not a strict prompt. It's not a filter you put on top of an LLM. The architecture itself is structurally incapable of hallucination.
It achieves this by operating under 3 non-negotiable covenants: sovereignty, determinism, and flat-file truth.
Okay.
But the governing rule that dictates every single action the software takes, down to the byte level, is what he calls the prime axiom of epistemic honesty.
The prime axiom of epistemic honesty. It states, and I'm quoting here, silence is preferable to fabrication, and a governed halt is the only professional response to ambiguity.
That's the one.
I want to linger on that for a second because I just love it. It is such a stark, almost aggressive contrast to the charming intern who just keeps talking to fill the dead air.
It fundamentally changes how the software reacts to errors or missing information. Think about how most standard software is designed today. It is built to fail open.
Fail open. What does that mean for the user?
Well, for example, if you are browsing a modern website or using an app on your phone and a small advertising script or a minor image fails to load, the software tries to gloss over it.
Well, like when an image is just a blank gray box, but you can still read the article.
Exactly. It bypasses the error, maybe leaves a blank space, but it keeps the rest of the page running to keep your user experience moving smoothly. It fails open to maintain momentum. The priority is continuity over perfection.
But Construct OS completely flips that. It fails closed.
Fails closed. If ConstructOS is calculating a logistical supply chain and it encounters a logic gap, a missing variable, or any ambiguity whatsoever that it cannot mathematically resolve to a state of absolute certainty, it does not try to guess a workaround.
It just stops.
It instantly halts the entire process. It freezes, it chooses absolute paralysis over an unverified continuation. It will literally shut itself down rather than risk writing a single fabricated number into a database.
Okay, so if the system literally paralyzes itself rather than making a guess, how does it manage the massive amount of messy information out there? I mean, the real world isn't perfectly structured. How does it organize what is true and what isn't?
To manage this, the system relies on a structural concept the blueprints call epistemic tiering. It literally classifies every piece of information it encounters based on how mathematically true it is.
So it creates a strict caste system for data.
Exactly.
Let's break those tiers down because the boundaries are incredibly strict.
The highest level, the absolute pinnacle of the system, is C1, which stands for resolved truth or atoms. For any piece of data to enter the C1 tier, it requires hard, irrefutable mathematical proof.
Absolute certainty.
Yes, it is the digital equivalent of that X-ray showing the broken bone. Below that, you have C2, which is a verified hypothesis.
And what fits into C2?
This is data that has strong empirical backing, perhaps high-confidence sensor readings, but hasn't yet achieved the status of a fundamental mathematical law.
Got it. And then there's C3.
Right, C3 is speculative data. This is human opinion, philosophical debate, unverified rumors, and the probabilistic guesses generated by LLMs. And this is the critical defining security feature of the OS. C3 data is categorically denied entry to the system's core memory. Speculation is physically blockaded from mixing with the C1 atoms.
Wait, if standard AI uses widely adopted languages like Python because they are flexible enough to handle all that messy data, what on earth is Price using to lock this system down so tightly? I mean, how do you enforce these tiers at a code level?
Here is where it gets really interesting on an architectural level. To enforce this strict tiering, the architecture uses a technique called dual substrate bifurcation.
Dual substrate bifurcation.
Basically, Price physically separated the computing environments. The core orchestrator, the brain of the operation, where the C1 truths are stored, runs exclusively in a programming language called LISP, specifically a variant called SBCL, or Steel Bank Common Lisp.
Wait, LISP? I know LISP is one of the oldest programming languages in existence, dating back to like the late 1950s. Why would he choose something that old for a cutting-edge AI architecture?
It is a very deliberate, almost philosophical choice. As you mentioned, many modern AI systems rely heavily on Python. Python is incredibly flexible, it uses dynamic typing, it is fast to write, and it is great for rapid iteration and experimentation.
Yeah, everyone uses Python for AI.
But from Price's perspective, that extreme flexibility is a massive security vulnerability. Python allows for arbitrary execution. It can easily change states or run unverified scripts on the fly. Python is just too ambiguous, too loose for the core of a truth engine.
So he actively blocks any arbitrary Python execution from ever entering the core. He builds a wall.
Yes. The core operates in Lisp because Lisp has a unique property called homoeconicity, which essentially means it treats code as data and data as code.
Interesting.
They share the same fundamental structure known as S-expressions. Because the code and the data are indistinguishable in their structure, it allows for incredibly rigorous, formal mathematical proofs to be applied to the software itself. Price uses a specialized environment called ACL2 within this Lisp core.
And ACL2 is what?
ACL2 is a mechanical theorem prover.
Let's translate that for the listeners. What does a mechanical theorem prover actually do in this context?
Think of it like a relentless, incredibly strict math teacher grading a geometry proof. Before any single function is allowed to execute and construct OS, the ACL2 system must mathematically prove that the function will behave exactly as intended under all possible conditions without any side effects or memory leaks.
So it's not just testing the code, it's proving it.
It analyzes the logic of the code itself and demands a mathematical proof of its safety. If the proof fails, the code simply cannot run.
The rigor required to build a system like that is staggering. I mean, the sources detail a specific audit process called DAP PTM 2.0 mapping. The architecture mapped 59 specific high-level semantic obligations directly into over 15,000 individual Lisp files.
Yeah, that's a massive undertaking.
And they state they achieved 100% code coverage.
Which, for anyone who works in commercial software development, is almost mythic. Achieving 100% code coverage without any dead code, without any unverified shortcuts or temporary stubs left behind by developers, it's incredibly rare.
It means there's no filler.
It means there is zero unauthorized entropy in the entire operating system. The system only does exactly what it is mathematically proven to do. Nothing more, nothing less.
Which perfectly contextualizes that incredible terminal log included in the source stack. We actually get to read the raw text of Price interacting with the interface L.O.R.I. right after he boosts the system up.
The log is a perfect demonstration of the fail-closed philosophy. Price decides to test the boundaries of this C1 truth tier. He types in a highly subjective philosophical question. He asks L.O.R.I, what is determinism?
Now, if you type that exact same prompt into a standard conversational LLM today, it would instantly, eagerly generate a beautiful 5-paragraph essay.
Oh, absolutely.
It would summarize internet definitions, quote famous philosophers, maybe compare determinism to free will, and try to give you a comprehensive, highly fluent answer.
But L.O.R.I doesn't do that. L.O.R.I analyzes the prompt, realizes it cannot mathematically prove a subjective human philosophy, and simply spits back a single line of text. Denied. C3 tooth ban.
Denied, just like that.
Yeah.
It doesn't even try to formulate an apology. It acts as the ultimate uncompromising bouncer for enterprise data.
It really does.
It recognizes that the definition of determinism is human language, subject to endless interpretation and debate. It cannot be reduced to a mathematically proven C1 atom. Therefore, under the prime axiom of epistemic honesty, silence is preferable to fabrication. It refuses to answer.
It is incredibly jarring if you are used to polite chatbots. But in the context of SAP basis and critical enterprise data, it is exactly what you want.
Definitely.
You don't want your hospital's inventory database waxing philosophical about the nature of supply chains. You want it to tell you exactly, down to the single unit, how many saline bags are in the warehouse. And if it cannot verify that number with 100% certainty, you want it to halt and alert you instantly.
But this brings up a massive underlying vulnerability. To achieve this perfect crystalline mathematical state where every action is a proven theorem, Price realized there was one chaotic, deeply embedded variable in every single modern computer system that was actively ruining absolute certainty.
Oh, this part is fascinating.
Yeah. To make ConstructOS work, he had to completely eradicate clock time.
This is where the architecture moves from brilliant software engineering into profound computer science theory. the eradication of time.
Sounds like a sci-fi movie.
It does. In his manifesto, Price argues that human clock time is entirely subjective. He points out that time warps based on our biological perception. If you are incredibly bored sitting in a waiting room, an hour feels like an entire day.
Oh, for sure.
If you are stressed or in a panic trying to meet a deadline, an hour vanishes in what feels like a second. When you go to sleep, you lose consciousness of the passage of time entirely.
He argues that time is a shared social convenience for humans, not a reliable mathematical baseline for logical machine operations. And technically speaking, when you look at how computers actually track time, he's absolutely right about the vulnerability it introduces.
Yeah, let's break down how a normal computer knows what time it is. It relies on a piece of hardware, usually a quartz crystal oscillator, that vibrates at a specific frequency.
Right. But the physical world is messy. That quartz crystal can be affected by microscopic variations in temperature or just physical degradation over years. The hardware clock isn't infinitely perfect.
Exactly. Furthermore, when the software tries to calculate time, it often uses floating point numbers. Because a computer has limited memory, it cannot calculate a fraction of a second to an infinite number of decimal places.
So it has to round it off.
Eventually, yes. It has to round the decimal off. It introduces tiny microscopic rounding errors.
And over millions of calculations a second, those tiny rounding errors accumulate. They create what is called synchronization drift across different parallel processes within the computer.
And that's a huge problem.
If you are building a system like Construct OS, where you are trying to mathematically prove that event A definitively happened before event B, and your internal clock is drifting even by a fraction of a millisecond, your entire mathematical proof falls apart. The math breaks because the baseline measurement is unstable.
So Price did the unthinkable. He looked at the architecture of the computer and he deleted the clock.
Just got rid of it.
He stripped standard real-time clock dependencies out of the Construct OS architecture entirely. The operating system literally does not know what time it is. And he replaced time with a structural concept called tau.
Tau is defined in the blueprints as a strictly monotonic sequence token. Sequence replaces schedule. When I was first reading this, I was trying to wrap my head around how a computer functions without a clock. And the analogy that crystallized it for me is the process of cooking pasta.
Let's walk through that because it beautifully illustrates the shift from time to sequence.
So if you are cooking pasta and relying on a clock, you might write down a schedule. I'm going to put the pasta in the pot at exactly 6:00 p.m.
Okay, sounds normal.
But what if the stove burner is broken? What if you forgot to turn it on and the water's freezing cold at 6:00? If you blindly follow the schedule, you throw the pasta into cold water and you ruin the dish.
The schedule is completely arbitrary. It assumes the environment will cooperate.
Right. It assumes a lot of unverified variables. But under the tau sequence, you don't look at a clock at all. You throw the clock out the window. You say, event B, putting the pasta in the pot, can only legally execute when event A, the physical reality, the water reaching a rolling boil, is mathematically proven to be complete.
Right, so it's event-driven.
You only act based on the absolute certainty of consequence, not the arbitrary tick of a clock. Event 1 must finish and verify its completion before Event 2 can even be considered.
That is exactly how Construct OS processes data. The entire system moves forward based on the verification of the previous step. And this tau sequence establishes a rigid four-state boot lattice that governs the entire life cycle of the system: genesis, clean, recovery, and fail.
Okay, and this fundamentally changes how the system handles crashes, right?
Yes. It handles the ultimate nightmare of any IT administrator, a catastrophic hardware crash, in a completely different way.
Let's compare the two. If a standard enterprise computer crashes, say the power grid flickers and the server shuts down unexpectedly, it drops whatever unwritten data was in its short-term RAM.
Yeah, that data's just gone.
When the power comes back and it reboots, it looks at its internal clock, realizes that 3 hours have passed, and it often struggles to figure out exactly what transactions got lost in the void. It fails open, tries to piece together its state from fragmented logs, guesses where it left off, and keeps moving.
Which, again, introduces doubt into the data stream. But if Construct OS experiences a total power failure, it doesn't care that the power was out for an hour or a day or a decade.
Because time doesn't exist for it.
Exactly. When it boots back up, it doesn't query a time server. It references an incredibly secure cryptographic ledger called the PIT chain.
PIT standing for provenance, identity, and tau.
Right. The system scans the PIT ledger and finds the very last mathematically verified event that was successfully written to the hard drive. It calculates the maximum tau value, the absolute last proven step in its sequence, and it simply adds 1.
Oh, that is so elegant.
It resumes its operations only from a perfectly verified state. It hasn't lost its place because its place isn't tied to the passage of time. Its place is permanently tied to the sequence of logic.
Okay, so we have built a computer that doesn't know what time it is, and a system that structurally paralyzes itself rather than guessing or predicting, which immediately raises the most obvious operational question. How does it actually solve a complex problem?
That is the million-dollar question.
If you have banned prediction, how do you ever compute an answer?
This brings us to the core solver mechanism of the entire architecture. This is the actual engine driving the intelligence. It is a process called residual guided kinematic convergence, or RGKC.
RGKC. It sounds like a concept pulled straight out of advanced physics.
Well, it borrows heavily from the math of physics and geometry. RGKC is the antithesis of how an LLM works. It does not predict answers. It doesn't search probabilistically through a massive data set hoping to find a pattern. Instead, it repeatedly applies lawful, verified corrections to eliminate residual error.
I found a way to visualize RGKC that makes it much less abstract.
Yeah.
It's like playing an incredibly aggressive, high-stakes game of Guess Who?
Guess who? The board game.
Yeah, you know the classic board game where you have all the little plastic faces flipped up on your tray?
Right. Where you are trying to figure out which character your opponent picked.
Exactly. When you play Guess Who, you don't just stare at the board for 3 seconds and magically guess that the opponent's card is Bernard.
Yeah.
You don't try to predict the final answer out of thin air. Instead, you ask binary, absolute questions.
Yes.
You ask, does your person have a hat? If the opponent says no, you ruthlessly flip down every single face on the board that is wearing a hat. You eliminate every logical contradiction.
So you are actively reducing the total field of possibility rather than just guessing the singular truth right away?
Exactly. You keep asking lawful binary questions. Do they have glasses? Flip. Do they have a mustache? Flip. You repeat this loop until only one single face remains standing. You didn't magically guess the truth. You systematically burned away all the falsehoods until the truth was the only thing left mathematically possible.
That's a great way to put it.
In ConstructOS, intelligence isn't fluent text generation. It is the measured geometric reduction of uncertainty down to absolute zero.
And to execute this guess who process computationally, RGKC operates in a digital arena called evidence space. Imagine a vast geometric grid with an X and a Y axis.
Okay, I'm picturing a grid.
The X-axis represents implementation evidence. This is the proof of how a specific computational directive is realized in the code. The Y-axis represents authority evidence. This is the proof of the governing mandate or law that allows that action to take place.
And the ultimate target, the verified answer, is coordinate 1111 on that grid, the absolute verified goal state.
Yes. When a problem is introduced, the system plots where it currently is on that grid, the incomplete, uncertain state. It then calculates the Pythagorean distance from its current point across the grid to coordinate 11,1.
It measures the distance to the truth.
Exactly. That geometric distance is defined as the residual error. The solver's only job is to recursively select mathematical operators that shrink that distance. It moves geometrically across the grid, step by step, closing the gap until the distance to the truth is exactly 0.
But how does the system ensure that as it moves across this grid, it doesn't accidentally take a wrong turn? How does it spot a hallucination forming mid-thought before it corrupts the path?
That's where cognitive kinematics verification comes in.
CKV.
Yes, the LISP core uses the CKV framework. This is where Price really leans into the physics metaphors, mapping linguistic logic to the laws of motion.
Let's break those down because this is the actual granular math of the truth engine. How do you measure the velocity of an idea? Semantic velocity, denoted as V.
Well, semantic velocity checks for logical gaps across sequential statements. It measures how cleanly and lawfully information progresses from step A to step B.
Give me an example of that.
Let's say the system is analyzing a logical argument. If A equals B and B equals C, then A equals C. That has a smooth, constant velocity. But if an LLM tries to argue that A equals B and therefore A equals D without proving the connection to D, the semantic velocity instantly drops. The system detects an anomaly, a logical pothole.
Okay, makes sense. Then you have semantic acceleration, or A. This identifies sudden context jumps. How does an algorithm spot a context jump?
It looks for massive shifts in the subject matter.
Right. Imagine an AI is generating a detailed report on the supply chain logistics for steel beams And mid-paragraph, it suddenly starts generating text about 18th century French poetry.
Yeah, that would be a huge red flag.
That massive, abrupt shift in subject matter registers mathematically as a massive spike in semantic acceleration. The context changed far too fast to be logically sound or relevant to the core task.
And finally, you have semantic jerk, or J. In physical mechanics, jerk is the rate of change of acceleration. It's that whiplash feeling you get when a car suddenly brakes and then hits the gas.
Right.
In Construct OS, semantic jerk catches severe analytical degradation across deep, complex execution chains. If the system is solving a massive multi-step logistics problem, and over the course of thousands of calculations, the underlying logic starts to subtly warp and lose its grounding, semantic jerk catches that underlying degradation before it reaches the final output. It detects the whiplash of logic failing.
And all of these kinematic physics acceleration jerk are mapped onto a strict geometric boundary called AMP space, or anchor mass property. The system literally draws the geometrical curve around the acceptable logic. This is the curvature check.
Yes, the curvature check.
If the reasoning of a process drifts outside that strict geometric curvature limit, the math fails. And because we know Construct OS fails closed, what happens if the curvature is breached?
The entire system hops immediately. There is no guessing. There is no attempt to gloss over the gap and smooth the sentence out. It triggers a hard, uncompromising stop.
Okay, listening to all of this, the LISP core, the ACL2 theorem proving, the eradication of time, the geometric evidence space, it sounds incredibly isolated.
That does sound like a bunker.
Yeah, it sounds like an impenetrable academic vault sitting in a dark room, totally cut off from the massive data flows of the modern internet. Does this system just exist in a vacuum?
Actually, no. And that is the most ingenious twist in this entire architectural saga. Price isn't trying to ignore the modern internet, and he isn't trying to destroy the massive probabilistic LLMs. He figured out a way to harness them safely.
The sources outline a concept called the virtualized swarm and the sovereign membrane. Price realized he could take his impenetrable deterministic architecture and use it as a containment field. He literally wraps Construct OS around massive probabilistic LLMs like Claude, Grok, GPT, or Gemini.
It completely inverts the current power dynamic of AI. Right now, most companies treat LLMs as all-knowing oracles. They ask the LLM a question and treat the output as the source of truth.
Right.
In Price's system, the LLMs are massively demoted. They are treated as untrusted, highly suspicious workers in the bullpen. They are utilized purely as stateless calculators.
Wow. Just demoted to calculators.
Yeah, they carry the massive, messy computational load of parsing millions of documents and generating ideas, while Construct OS sits above them, acting as the strict, unforgiving governor.
He essentially forces these trillion-dollar guessing machines to submit their homework to his localized mathematical truth engine before the human user ever sees the answer.
Exactly.
To achieve this, he built a 5-phase execution cycle, and he integrated it directly into the local file system, specifically utilizing Google Drive folder structures in the blueprints.
Let's walk through that pipeline step by step because it perfectly visualizes how the sovereign membrane protects the user.
Yeah, let's say I'm sitting at my computer running Construct OS. I type a complex data query into L.O.R.I and hit enter. What actually happens? Phase 1 starts right there.
Phase 1 happens in a local directory called 01 proposed. You ask L.O.R.I the question, but L.O.R.I is physically forbidden from connecting directly to the internet. It cannot talk to an external API.
Okay.
Instead, L.O.R.I takes your request, translates it into a highly strict formatted JSON schema, which is basically a rigid digital contract, and simply drops that JSON file into the 01 proposed folder on your hard drive.
So it's essentially just leaving a note in an inbox. It doesn't send anything anywhere.
Exactly. The moment that file hits the folder, phase 2 triggers automatically. This is the O3 reversal ready phase. Before the system even thinks about processing your request, it takes a snapshot of its current mathematically verified state. It backs up the entire core, locking it down with SHA-256 cryptographic hashes.
Unbreakable digital fingerprints.
Yes. A hash is essentially an unbreakable digital fingerprint. If anything goes wrong in the next few steps, the system has a perfectly preserved, mathematically proven state to roll back to.
I love that. It's securing the safety net and checking the anchors before the acrobat is even allowed to step onto the high wire. Once the system is locked, we move to phase 3, 02, unverified state.
Now the system finally reaches out. A separate piece of software, A Python daemon running invisibly in the background sees the JSON file in the proposed folder.
The Python daemon handles the messy part.
Right. It takes your prompt, wraps it in a massive hidden list of strict structural rules, and sends headless API calls out into the cloud. Headless just means it is communicating computer to computer in the background without a chat window or user interface.
Okay.
It sends the prompt to the swarm of LLMs, Claude, Grok, whoever is in the bullpen. The LLMs do what they do best. They analyze the data, they do their probabilistic guessing, and they generate a text response. They send that response back to your computer. But, and this is vital, that response does not go back to L.O.R.I.
L.O.R.I is shielded from it. The LLM guesses are dumped straight into a quarantine folder, 0, 2 in verified state. The LLMs are kept outside the vault. Their guesses are treated as highly suspect, potentially toxic hypotheses. And this triggers phase 4, which is where the absolute magic happens. The truth engine engages.
The local LISP kernel, the brain we discussed earlier, wakes up. It reaches into the quarantine folder and grabs those LLM guesses, and it subjects them to the absolute brutality of the RGKC kinematic math.
It runs all those checks.
It checks the semantic velocity, are there logical gaps? It checks the acceleration, did the LM jump context? It checks the jerk, is the reasoning degrading? It runs the ACL2 theorem checks to verify every single logical transition the LLM made. The LISP core is actively trying to break the LLM's logic using geometry and physics.
It is stress testing the guess until it breaks. And this leads to phase 5, the final verdict. Let's say the LLM output miraculously survives the truth engine. It is proven to be mathematically sound with 0 variance. What happens?
If it passes the math, it is promoted. It gets moved from quarantine into the O4 verified DC1 folder. Only then, once it is a mathematically proven C1 atom, does L.O.R.I read the file and speak the answer back to you on the screen.
But what if it fails? What if the LLM hallucinated even one single byte of data? What if it guessed wrong?
It instantly triggers the fail closed protocol. The system dumps the corrupted LLM output into a final folder. Jo5 quarantine, the entire process halts. The user interface freezes the query. And the system automatically generates a highly detailed diagnostic email.
What's in the email?
It contains the exact point of failure, the specific semantic kinematic metrics that were breached, and the hash mismatches, and it sends that report directly to the system architect.
So as the user, you never even see the hallucination. You are completely protected from the slow rot. You just get an alert that the LLM tried to lie to you, and the system caught it at the gate.
It's an incredible defense mechanism.
It is absolutely brilliant. It allows you to leverage the synthesized intelligence of a trillion-dollar corporate data center. You get all the massive parsing power of Claude and GPT, but it is entirely filtered through an uncompromising mathematical governor on your local PC that physically cannot lie to you. It is the ultimate firewall for truth.
And it doesn't just block lies, it learns from them. The sources mention a background process called a reflection engine.
Oh, how does that work?
It logs every single time an LLM fails a kinematic check. Overnight, while the system is idle, it analyzes those failures, extracts the specific patterns of heuristic drift, and generates new parameterized templates to preemptively catch those specific types of hallucinations faster in the future. The system constantly hardens its own membrane based on the failures of the swarm.
Which brings us to the most shocking revelation in this entire stack of sources, and it has to do with the physical hardware required to run all of this. We're talking about 15,000 lines of rigorous LISP code, ACL2, formal theorem proving, complex semantic jerk physics calculations, and a sovereign membrane managing API calls to multiple massive LLMs.
It sounds like a lot of heavy lifting.
Right. You would naturally assume the physical hardware required to run this impenetrable fortress would be massive.
The current unquestioned assumption in the tech industry is that advanced AI requires supercomputers. We are currently watching companies locked in a multi-billion-dollar hardware arms race. They are building sprawling data centers that consume the electrical power grids of small cities just to stack up massive clusters of thousands of GPUs or graphics processing units to run these models.
But ConstructOS proves the exact opposite. The blueprints explicitly state that the entire core LISP codebase for this architecture is under 30 megabytes.
It is incredibly, almost impossibly lightweight.
Under 30 megabytes. A single high-resolution photograph taken on your smartphone is larger than this entire operating system. And it requires absolutely 0 GPUs. It runs entirely on a standard retail CPU and normal computer RAM. It operates on roughly 20 watts of electrical power.
Which is a very specific, deliberate number.
Why 20 watts?
20 watts is designed to perfectly mirror the natural energy efficiency of the human mind. The human brain manages incredibly complex, deterministic logic and survives in a chaotic physical reality using about 20 watts of continuous energy. Price built a system that mimics that efficiency.
But how is that mathematically possible? How can a system doing this much complex geometric math and theorem proving run on a standard off-the-shelf desktop PC without a graphics card, using less power than a traditional light bulb?
This is the ultimate genius of determinism. Those massive hardware scaling costs we see in the industry, the billions of dollars, the power-hungry data centers, the thousands of GPUs, that is not the inherent cost of computing intelligence.
What is it then?
That is the exorbitant, wasteful price of guessing at scale.
The cost of guessing. Explain that.
Probabilistic LLMs have to maintain vast, multi-billion parameter spaces in their active memory. When you ask them a question, they waste billions of compute cycles exploring undetermined future states, calculating complex statistical probabilities for thousands of words they ultimately will never use.
Oh, I see.
And when they guess wrong, they spend massive amounts of compute power trying to recover from bad predictions and generate new ones. It is incredibly inefficient. Construct OS, on the other hand, never wastes a single compute cycle exploring a guess.
Never.
It never has to repair a flawed prediction because it only executes what it can mathematically prove in the sequence. Determinism in this architecture is not a bottleneck. It is a massive accelerant. It completely removes the computational friction of ambiguity.
That completely upends the narrative of the entire AI industry right now. It shifts the entire philosophical stake of what we are building and what we are investing in.
It really does.
In his audio manifesto, Price argues that the tech industry effectively moved the goalposts. They realized they couldn't figure out how to build actual verifiable truth into a neural network, so they simply redefined the word intelligence to mean fluent guessing, just to justify the probabilistic models they had already built and funded.
He argues that accepting a 95% confidence interval in our critical infrastructure isn't just an engineering compromise, it is a profound moral failure.
Yeah.
He states very plainly that he built Construct OS out of a sense of protection. He believes that humanity deserves absolute mathematical certainty, not a statistical guess, when it comes to the systems that will eventually run our hospitals, our aviation networks, and our enterprise data.
And he proved it can be done. By one person operating entirely outside the traditional Silicon Valley tech hubs without billions of dollars in VC funding.
It's a huge achievement.
So what does this all mean for us? Let's trace the incredible journey we've been on today. We started by looking at the very real, very present dangers of the mimicry fallacy, how the charming intern of current AI masks probabilistic guessing with conversational fluency.
And we saw how that fluency leads to the silent, catastrophic, slow rot in zero-margin enterprise environments like SAP basis, where a single hallucinated number can poison a database for years.
We then examined how Construct OS serves as the ultimate architectural countermeasure. We explored its strict fail-closed philosophy and its rigid epistemic tiering, utilizing LISP and ACL2 theorem, proving to physically deny entry to unverified speculation.
We looked at the audacious, mind-bending technical moves required to achieve that certainty, like the complete eradication of subjective clock time in favor of the strictly monotonic tau sequence,
ensuring perfect unwarped crash recovery through the PIT chain.
And we broke down the core solver, residual-guided kinematic convergence. We visualized how it uses geometric evidence space and cognitive kinematics verification, measuring semantic velocity, acceleration, and jerk, to ruthlessly burn away falsehoods until only the absolute truth remains.
Finally, we saw how this tiny 30-megabyte, 20-watt system can be deployed in the real world as a sovereign membrane, a localized, impenetrable vault that safely harnesses the massive power of the world's largest LLMs without ever letting them lie to the user.
It is a monumental achievement in software architecture and a profound challenge to the current trajectory of technology.
Which leaves us with a final, provocative thought for you to ponder as you go about your day. If a single, independent architect working alone, outside the echo chambers of big tech, can build a mathematically pure, truth-telling artificial intelligence, and if you can run it on a standard desktop PC without a single GPU, using the exact same amount of power it takes your brain to process this sentence, what does that say about the billions upon billions of dollars currently being poured into massive corporate AI models? Are we engineering actual dependable intelligence for our future? Or are we simply funding a very expensive, highly fluent, and incredibly fragile illusion? We started this deep dive talking about X-rays. We rely on them because they cut through the surface and give us the hard, undeniable truth about what is broken inside us. As we continue to integrate artificial intelligence into the very skeleton of our society, we have to decide. Do we want an X-ray that shows us the hard mathematical reality? Or are we okay with an X-ray machine that just paints a pretty picture and guesses what we want to see? Thank you for joining us on this deep dive. Until next time.